not record any of that? Huh? That's okay. That just means I get to give it somewhere else. Yes. Yes. The feature manager. Huh? Feature tree. I'm not sure if you, yeah. I know you can the command manager. I know you can the other window. I forget what the name of it is on the right. Yeah, exactly. There's a lot of stuff you can, but I don't think that's one you can. Yeah, I can definitely see that because I know that the one that's on the right side that has your tools and all that stuff, SolidWorks home button, task pane. Yeah, I undock that all the time and put it on another screen. Yep. You can hide it. Yeah, we mentioned that. You can actually like minimize it. Minimize it.
Submit as an instant request.
Yeah, that's interesting. That's an interesting topic in itself. So space mice actually, if you like mouse gestures, will actually give you another set of mouse gestures. So that's cool. Any other questions? You want to say that a little louder?
So Chris in the chat said that invert selection is a good one as well. It's good to select a few things that you want in a new display state. Then invert it to a mass height in a larger assembly.
There's like a few items that you can select. If you do the inverse, it makes
Everything else.
I mean, put like the bolt off. You can actually select similar parts. It's bolts are effective, right? You got a item select all these bolts. You all make a display thing or whatever shows like you look at what performance. There's a filter selection. I recommend you guys wouldn't do that. I didn't realize all the different things in your filter selection.
Yeah, that's what I meant. That's why I mentioned that earlier in the presentation that most of your power users have filter selection available. Even if you don't have it available, you at least know the F key that brings it up and puts it down. Yeah.
No, it's
F5. F5.
It's selection filters and it tells you all.
You know, it's a hotkey.
It is.
Every single user that uses the software for the first time, that key somehow, and then the kid's like anything.
Yep.
I think it's because an inventor, he can dimension, if it's needed, it filters something. F7 is how you get out.
Yeah, you might be right. For
Oh,
F5,
that was the issue with indicators.
and F5 and Windows. Because we never get the F5 button. Yeah, I know when I was teaching. People, hey, you see that little thing next to your cursor? That looks like a phone. So what's the worst kind of like F4?
That is a good way to remember. Yeah.
Turn me on the next. It's working. It's great. I can't remember. I think it's F4, F5. Anybody? I had students like shutting.
It's F5. Right. It's F5.
Yeah.
Yeah. Here's your on the Mac. Not on the Mac. I don't know Mac. I'm a Peterbilt. Yeah, right there, the F5. D won't do nothing for you here. Not on my computer, it won't. D is the breadcrumb. D is default breadcrumb. Mine's R. But that's because of my macro path. What I was gonna say is when you bring in, say, the gusset, right, and you go to start mating, and you hit that Alt button, you see how it starts taking faces away? You don't have to use any mouse buttons. You just hover over it, just like the shit control tab stuff, right? Yeah, you can right click and do select other, and it'll select the ones behind and give you a list of all that. X escape. Doesn't seem to. Oh yeah, Shift Alt. Transparent is my favorite color. So in that option, the Alt key makes it transparent, so you can click the face behind. Shift Alt brings it back. But now that's only effective in the mating scene. You have to have mating enacted before it works like that. It is. Even for my buddy Tank. All right. So if that's it,
All right, so we're going to get started on round two, I guess, presentation number 2. So we're gonna go. Hold on a second. Why is that in the way? Move that out of the way. Parts that cannot be made efficiently or inexpensively. So we'll go from there. Come on now. There it goes. All right. So my name is Brad Meador, also known as Tank. I'm a project designer at Altec Industries. I've been there nine years, almost 10. 15 years as a SOLIDWORKS user, and I have got my CSWE in 2018. Personally, I'm a husband and dad, motorcycle minister. I do the project design job. I mean, all this vast free time, I'm also enrolled in electrical engineering as well, because why not cut another 3 or 4 hours of sleep out a day? So let's just, you know, keep the insomnia going. So today we're gonna go over parts that cannot be made cheaply or efficiently. Just kind of a little bit of a segue from my design intent for dummies that I did yesterday. What's the primary goal of an engineer? Okay, by what? By designing. Okay. Some of them are illegal, yes, but you know, by getting parts made and designs made, right? Yeah, cost effectively and efficiently, right? Well, do you always know how to do that as an engineer? No. How many of you guys back here, guys and gals, actually work direct one-on-one with a shop machinist or shop, you know, foreman? Okay. Anybody have actual CNC or machining experience? Oh, I like that. All right. So this actually might be, you know, some old news to people. This is good. I'm kind of liking this. This is good. Because my role, part of my role as a project designer in Altec, is I get to mentor new hires, co-ops, interns, and we have this new program launching early next year, where I get to mentor high school students that are in engineering career fields. So one of the things I find,
Form, fit, function.
Form, fit, and function. Yes, it is form, fit, and function. So part of the one of the biggest things I see coming from new hires or co-ops or you know, high school students or, you know, even down to middle school is they come up with these nice, really cool, crazy ideas without an idea of how it's made or how they can efficiently get it made, right? Kind of goes back to the design intent thing I was talking about yesterday, was how to bake that into your parts themselves to show them. Now, if you've been working in the field for 20 years and you've got a machinist that you work back and forth with really well, you know, some of this might be some, you know, repeated things, but you know, we'll go from there. So we'll kind of go with we'll start with design intent, right? What is design intent? Well, the Merriam-Webster's dictionary is the technical description of the part criteria defined by the designer or the engineer. And sometimes that could be in conflict with what can be made, what can actually physically be made. You know, now there are some new technologies out there, such as 3D printing or the wire EDMs and things like that, that can make these more complicated parts a little bit better, a little bit more easily manufacturable. But, you know, sometimes we have to change our designs to meet those manufacturability concerns. There's an entire career field around DFM, you know, that's the sole job of that group of people, is to figure out how to take this design and actually make it. So, but in SolidWorks, I like to say it's how the model should behave when it's changed or when it's, you know, when it's being modified or being updated by a new user. So we'll kind of jump back into one of our a really nice. Let's jump into an example here. Kind of something I don't want to cancel. I don't want multiples here. That's after you have the part made, right? Right. So we're going to jump back to kind of a my first example I had last night, just to kind of go over some stuff here. We'll kind of throw this in, and all my hotkeys are backwards because this is Adam's machine. We've been sharing one, so as I get in here, I've been making changes to his hotkeys and really throwing his presentations off. It's been kind of fun. But I won't do that tonight to him. So
Yeah, my shift C no longer classes the tree anymore.
I know it really bugs
I don't
me.
know what happened during this week, but my shift C does not class the tree.
I don't know, it bugs me. All right, so we're going to take this plate here. We're going to make it 10 gauge, and we're going to throw some holes in it. And because I'm big on user participation, if you guys have questions, stop me while I'm in the middle of the presentation, and we'll answer them as we go. That way, we don't end up confusing people more and more. So we'll just go from there. So we'll throw some holes in, and we'll drop them in and kind of space them out. We want them centered. But we're going to need some dimensions in here, and I want to see if anybody will be willing to help me out here. Give me some dimensions. We're going to center this up across the part vertically, but horizontally, the floor is you guys. Tell me what you want to see. I don't know. Do you? That's not my job. To make all these equal. Okay. Let's see. There he is. I try to call out my hotkey, and it messes it up. All right. That's a lot. Apparently Adam's very precise with his really thin sheet metal parts.
Again, my computer needs to be reset after this week.
So we're gonna send this directly to the machine shop and have them make it to 8 decimal places. All right, what size hole do you guys want to tap in there? We speak freedom units.
You will submit.
What tap size? Quarter 20. Okay. All right. So we got this kind of here, and we've got this one dimension. Now, if we're going to send this off to the machine shop, how would you think they would like to see it dimensioned? If at all,
Because I know a lot of times we got machine shops now that don't dimension things at all. They just take the DXF of the model and do everything CNC wise. But we'll just kind of just save this in real quick. We're gonna do the cardinal sin and just leaving it named part 2. And we're gonna create a drawing. Pro tip, if you do a lot of repetitive things, set your templates up. As you can see, we have tons and tons of templates, all the way down to even our certification exam templates set up so that our users can rapidly create parts as they go. Because
Yeah, once you get into the higher versions of the certification, templates will definitely help you out.
okay, so if I want to make this part, right, we know it's 3 inches from one end and they're all equally spaced. How would you dimension it? I don't know. That's my. I'm just the drafter here. You guys are the engineers. Okay. All right. So where would the baseline be on the end? That's where your first dimension is. So we're just gonna kind of run back here. So this is all really good examples of design intent, right? Now, because we have this set up this way, if you look at our giant tolerances compared to some people, I mean, look, we have 16th of an inch tolerance on 2 decimal places. It's because we make things that are 30 feet long. And if I can look at it and go, that's enough. Can we use a hammer to put it back in place? Yes, then we're good. But because, this is the way you kind of set it up, you've got the design intent to where you've only got a plus or minus 16 of an inch on each hole. Now, if we were to daisy chain them, we know that they could stack. You have this big giant tolerance stack up.
Yeah, if the hammer or mallet doesn't work, it come along with it.
Yes. Hammer, mallet, blowtorch, forklift. I have seen that happen.
We usually test things on forklift.
Yes.
Them, jump up and down.
Yes. So this is all good ideas of design intent, right? How you dimension it, how you lay out the part to be made. But when we go into
Chris said heat, beat, weld.
heat, beat, and weld, yes, but you get what you design, or kind of close enough, because we don't, as designers, sometimes we don't care about the little minutia of the details, right? So I want this cavity, right? I can send it directly to the machine shop just like this, because all the critical dimensions are there. Can it be made this way? Would it come in correctly that way? Okay, what do you see wrong that cannot be done right now? Vertical angles, hard edges, what else?
Well, I mean, your vertical faces, you're not gonna get those things.
Yes.
You gotta change the angle of it, picture.
Yes. That's all. And this is all things that's got to be considered when you're making a design. And this is a lot of things we run into with new hires or people who just haven't been explained really well, or somebody who's not had machine shop experience. They know, okay, well, this part gets it done. It's quick. It's dirty. It's on the floor. Now, if I was to pick this part up and it was made exactly like this, it'd be kind of dangerous to handle, wouldn't it? Sharp edges everywhere, probably burrs all over the place. It'd be be difficult. So how would we go about making this? We're just going to go in the hypothetical situation that says we know our machine shop has a 1/2 inch radius end mill, right? Or a 1/2 inch diameter end mill. So what does that mean? Our machine tool radius can be. It's a half inch diameter. So what? Be a 1/4 inch. So you would think logically we could do a 1/4 inch radius to get our finished on the verticals. Now, if it's a ball end mill, we might be able to get them radiuses on the bottom. If it's a flat, no. Correct. So the good point about the things about this is you're gonna have to start working back and forth with your machine shop, figuring out what the capabilities are. Yeah, I mean, we could probably cut this if you do like a sinker EDM, if you really want to do something and have a counterpart made out of brass and do a sinker EDM to get the exact cutout that you need. Yes, it's doable, very expensive. You're looking at $10,000 or so for one piece of billet.
Diminishing returns.
But you can 3D print it, correct? 3D metal printer, but again, still very expensive.
At some point, yeah, at some point you have diminishing
Yep.
returns.
At some point, you got to look at your diminishing returns. So I know that I've got a 1/2 inch end mill, so we can kind of go in here and we can say a lot of our external radiuses, radiuses. Listen, I'm from I'm from a little small town out in the woods, so you're lucky that I could even know English all the way.
But we do know how to ride motorcycles.
But I do know how to ride motorcycles. It's a fillet, yes, a filet mignon. And you serve it with champagne on the side. Champagne on the side, yep. So we know we can kind of come in here and
Smart fillet. Yeah.
yes, you can do a smart fillet if you want, but I'm just kind of going just
Fillet expert.
fillet expert, yes. Yes,
Somewhere.
I'm obviously not in this room. So it's something that's adding one feature on your part will make it cheaper to make, safer to handle, and easier, at least easier to manufacture for our machine shop. They'll thank you immensely because they'll be able to rapid knock out these parts, and they're not sitting here having to measure everything down to the minutia because they're not having a tool change, right? Has anybody ever seen like what a tool change is involved in on a machine? Yeah, because if you have to re-index the part and change call it out to have a really small tool, get these really sharp edges, it becomes really labor intensive, and that always equals cost, right? Lots of cost everywhere. I mean, yeah, they'll make it for you. You're going to pay for it. Yeah. So we one of the things I like to preface with all of our new hires and engineers is, even just looking at base and putting some pieces on the end. They might think, oh, it's more complicated, but it gives the machine shop something to work with. They can actually run their tools. A 1/2 inch. My mic's gone. Oh, I'm sorry. I talk loud, broke the mic. All right. So
For your beard and fisted it.
maybe infested it. Oh, look, we're gonna go snooze this thing again. Let's hope we can make it to the end before it goes out. So again, you get what you design. If you want to have something that's super sharp, super complicated, you're going to get it. But is your boss going to be happy with the price or with the lead time? No. Okay, so we're going to kind of jump over to my mistakes because I'm really good at showing how I messed up. I'm not too proud to do that. So
Nobody's ever looked back at a design 5 years ago and said, "What the heck was I thinking?"
has everybody ever done that? I mean,
Well, 10, 15.
yeah. 5 days. Oh, if you're not that's a good. If you're not constantly improving, are you actually doing your job? Ooh, okay. So here in this is a we call it a wear pad boat. Wear pad sits in this pocket, and it actually floats down on a counter machine. It allows you to flex back and forth when the part is bent or rotated around. Now, this was actually what I sent out to the machine shop because it was prototyped. I needed to get it done. What do you think I got?
We can't do this.
I wouldn't say I got cussed out, but I did get an email. It was very not friendly. The first thing they asked was, "What tools do you want us to use? And how much is your budget? What is your budget?" I said, well, as cheap as possible, and I need like 5,000 of them by the end of the year. And they looked at me, or they responded back with, it ain't happening. So I know this wear pad's going to sit inside this square boat here. How would I actually make that fit? Okay. Yeah, keyholes, right? Or relief cuts. I think some, depending on what company, what standards you want to do. Yeah, we can come in here and drop in some. Say what? Yes, that's a good one. I like that too. Having like some standoffs that only touch the base. Yeah. We're just going to kind of throw in a 1/4 inch keyhole here just to show. Yes. This is all made out of aluminum. I mean anything right, any metal right now is not cheap. So unobtainium, yes. Corium. No. So it obviously has to be profiled on the bottom, right? So but do I need these edges sharp all the way around? No. In fact, making those edges sharp is probably detrimental to the person who's assembling it, right? So putting fillets or chamfers in, fillets for us Southern people, fillets in. But yeah, what about these edges here? How would I go about, getting this thing to sit flat? Okay. Just maybe oversize the pocket just a little bit. Okay. Okay. Yeah, that's good. I like the standoffs idea, putting a little standoff left, right, top, bottom. Little locating plates. Yeah. Well, I wouldn't say a stroke of genius, as close as I could get to a stroke of genius. That's what I came up with. In about 15 minutes, I'm like, what do I do? And the guy's like, look, he's like, you can't get these sharp corners. We can't machine them. So I threw some keyholes. Some of them call them mouse ears. I've heard them called Mickey Mouse ears or something similar in there. And it dropped the cost by a significant figure, like an actual zero at the end of the cost. Yes, it dropped the whole placeholder because they went from being able to have to EDM it out or go super tiny end bills and get down to where it's just 30 seconds radius down to be able to just throw in a 1/8 inch or a 1/4 and just hog the whole thing out. Yeah.
Chris Robertson on the chat was talking about a flat bit or a milling bit.
Yeah, a flat bit or a milling bit would be able to do it. Yes. Yes.
I mean, I don't know how long that part is.
So the length is 6 inches.
Yeah, so you could possibly position it twice
Yes.
on the end.
Mhm.
Drop it down and fix it.
Yep.
And I'll get down.
Yes. I don't know how they did it because I never asked. All I know is that after on most everything we do, it's 2 decimal places, so plus or minus a 16th. Because everything we do is 30 and 40 inch, 30, 40 feet pieces of sheet steel that are getting bent sometimes 2 or 3 times and welded and hammered and some. An 1/8? Okay. Okay. Plus or minus an 1/8 is still pretty good. Okay. We're going through and just doing ideas of like things that I showed examples of, solutions to my problems that I created because I didn't have the proper design intent or I, wasn't communicating well with my shop. So this is kind of another one on this giant. This is previous career. I worked in the military. Worked for the military, and we needed this tapered collar that had to be tapered at a certain angle so a piece could fit on it, heat shrunk on. This is exactly what it needs to be, right? It's exactly what it needs to be. This guy who does nothing but forge stainless forgings looks at me and says, "Are you serious?" He was being asked to taper this within a 4 decimal place tolerance, because that's our internal, at the time, that was our internal tolerance across this entire face to heat shrink apart on. Now, they got a guy? You got a guy? Okay. How much does that guy cost? Okay. But in this situation, I didn't mean to, I should have told you, this part is, where's your measuring tool? It's 15 inches in diameter. Throw you a curveball.
Chris said sand cast in the mill.
Sand cast in the mill, okay. To get to, but don't you think that I don't want to have this part press fit across this entire face, right? I don't need it. Like, once this piece gets put on, it's never gonna, it doesn't need to have that much engagement. So we actually went through and jumped into SolidWorks into our CAD machine here and decided, well, we're going to decide to scoop out some material out of it, and only had a small section of it. I don't know why it's doing that, Adam. We had actually ended up taking only a small section. We actually ended up knocking off like 3 inches off the actual taper so that you could actually slide this thing on a little bit more efficiently and save some cost on it. And this is things I've just learned over my career, just playing around with this stuff. Now, could I make this even better? Instead of tapering this entire face, how would I go about making it a little bit easier to put together and a lot cheaper to machine? There was a rotor that needed to be engaged, and it only needs, really one small touch point because it's heat shrunk on. Yes, which is only about 3-4 inches, right? Yeah, in theory, yeah. So I mean, I could have gone back in, changed this dimension here to, I don't know, 6 inches. And tapered much less of it, or even more, or even less, and just had this extra stuff just kind of hogged out and rough machine, right? Oh yeah, now mine's starting. Oh, I guess we got to do that tonight before we go to work. Okay. Yes. Chris also said multi-part. Yeah, you could probably also machine really tight tolerances on one piece and either bolt or weld, a non-critical part to it. That'd be another way to do it. But these are the things that I've come across through my time, I guess, through Altec or through other careers that, I can design anything I want that I can put on my brain and put on paper. As long as SolidWorks will do it, I can send it to the machine shop, but can it be done? Can it be done? But again, like I said earlier, these new 3D printers and wire EDMs and plunge EDMs and things like that, those can be done now. It's just a matter of how much are you willing to pay for it. Yes. Is it needed? Yes. So I'm gonna we'll just kind of go into a drawing, right? Because that's ultimately what we want to see. So we're gonna go here. All right. This is actually one of our pins that we have. And you can see we got some tolerances in here. We got some surface finish in here. It's a welded piece with a pin flag on it and looks like a really, really smooth surface finish on this pin that gets slid through. It only has 2 engagement points that are 4 inches total, so 2 inches on each side. Do you think I need to keep that much of a tolerance over the whole length of this 20-inch pin at that surface finish. This is a $600 pin currently. That's well, it's only the two ends that actually touch. There's two bearings at the ends. That's it. The inner pieces don't need to be there, right? I mean, you think this looks pretty simple to machine, right? Yeah. But, you know, if I come in here and we'll just kind of do some little in context cutting, because this is two pieces that are, you know, internally saved, which is terrible. Don't do that. Do not do internal virtual parts. Please don't. I hear laughing.
Sounds like you've been down that road.
Please don't. So what we will do, we'll drop in a sketch here. And this is something that, this is actually a current part that I'm working on getting requoted to be cheaper. So this is kind of to kind of show you what we can and can't do. So we're going in here. You know, we know that there's only, I don't know, a two inch wide. Adam, hotkeys are backwards. We know there's only a 2-inch margin on each end that really need to be profiled appropriately. Come on now. Oh, did the camera go back off? Ah. Oh, wait. Forgot my center line. My apologies. Nope. Forgot my center line. Because, you know, everything works perfectly when you do live demos. Always, right? Nothing ever breaks. Computers don't try to restart, nothing. Say that again. Yeah, that's
45 minutes, I don't think would have cut it.
yeah, I don't know that. I don't think it would have. So, you know, as a designer, when I first started doing this, I figured this part, something along this line would be more expensive to cut because there's more material to remove, right? But it's not about the material that's actually being removed. It's about the tolerances and the measurements that they actually keep. How many people know GD&T or actually have studied GD&T, geometric dimensioning and tolerancing? Okay. Okay. Yep. Okay. There we go. All right. I like that. All right. A little peer pressure to make everybody to say things. All right. So, you know, I would want to have this, just these two ends, GD&T to where it needs to be, and then that on the part. These would be the only pieces that need to be surface finished. The rest could be what, 250 or 125. The guy who's running the lathe can just hog out the material real fast and only do the super critical parts and then weld it together. It just saves a lot more time than having to sit there and run a 20-inch piece of perfectly round 16 micro-inch finish. This again, little things that not many people think about until they actually get the quote back and they go, huh, why am I spending $600 on this part instead of $250 or $125? Just little things like that. So, but since we got about 9 minutes left before our allotted time's up, I'm going to just throw it over to a general stump the chump or ask questions about the presentation or anything SOLIDWORKS related. I will jump into the program and we can try to break it if you want. Me. What does the Alt key do when you use the Mac? Adam, does your magnifying glass even work? I'm scared. I'm scared to hit the G key. I don't know what's going to happen. Whoa.
Back and watch the peripheral, presentation,
Look-
understand.
Look what happened when I hit the G key. Look at the file. Ready? Instead of the magnifying glass, it goes to read only. I've never seen that.
So the reason I do that is because like everything read only in our system is when we download it.
I'm gonna tell your boss. What happened was gangster. Oh, sorry. Magnifying.
Without it being checked out or whatever, then it doesn't save in. Well, I understand.
Okay.
Sometimes I have to modify things before I save it off.
And scroll.
Live section.
Mhm.
It's really good tool. It's a really good tool. You know, there's parts here, you got magnifying glass, magnifying glass.
Yeah.
You hold all.
And then zoom in. Here's lab section view.
Doesn't work well on blocks. Blocks.
Like this group is so much fun. I like this group. All right, so here's an assembly, okay? Or you want to see what it does in an assembly? Uh-oh. It works on a part.
Parts, not assembly.
Uh-oh, I think we broke Adam's machine.
We did it.
Yep, we broke it. Yeah, hold on, button. Yes.
I have to go back and watch the peripheral presentation to understand why.
Yeah, see, look, it did shift on the flag. Yeah, hit the alt.
Shift or tab. Yeah.
Shift, it doesn't. Nope, not doing it.
Yeah, you can't do your hide and stuff.
But then again, this well, I mean, again, in all fairness, this machine, all the hotkeys have been changed, so something might have been turned off. Because, like I said earlier in the week, he's an anomaly. He just does everything completely backwards.
So actually, where it started with some of the hotkeys, the old solid edges. And so some of the hotkeys I got used to install it and I brought into my SolidWorks.
Yep. Boom.
And then from there, it went back. So.
Yeah. Again, anomaly. All right. Any more questions so far?
And then Brad did preference that he messed a lot of them up.
Yes, I did. I intentionally messed a bunch of them up while I was working on stuff. I was changing his hotkeys around.
But how do you fix that?
How do you fix it? Save your user settings.
Restore.
Restore from your user settings. Yes. No, oh, listen. Do you own are you a gearhead? Anybody here a gearhead? Customize your stuff. You don't ever keep your car stock, do you? Even if it's like changing floor mats out. You know? So, I mean, Adam's customized his. On what? Oh, oh, shots fired. I like that. All right. Any more questions so far? It's that blue and black one out there. It's a 2010 Harley Ultra Limited. She's an old cantankerous lady, but sometimes it's fun to, you know, go on motorcycle rides.
Yeah, 'cause we didn't tell you guys about the start of the ride where,
Yeah.
you know, Stater